Well, welcome everybody. This topic is one that I love. I think it's really pretty cool. A lot of things that you can do with mapping and spatial analytics. So it's a fun one to cover. And as Kim mentioned, this is kind of like adding on to what we've already learned in some of the previous sessions about desktop and prep and server as a business user and those sorts of things. So with that, I do have some slides to kind of intro the topic, and then we'll spend some time kind of showing exactly how spatial analytics works with Tableau. Just a quick notes here. If you need to reach us, Henry Wisniewski is the account exec for your account. I am the solutions engineer. I have been working with the state for the past 6 years or so. So I know all the folks, all the players. I probably have met a lot of you at various points during our working with the state. The state does already have Tableau installed, so it is definitely something that I encourage all of you to take advantage of if you haven't already for your analytics needs. So with that, just a quick review of the platform for those of you that aren't familiar with Tableau. So when we look at doing analytics, the very first thing that we typically have to deal with, well, not typically, I mean always, is where we're getting our data from, right? So we've got our systems of record, and that could be everything from Excel to industry standard database, like you have there, like SQL Server. It could be Oracle, or it could be an application. It could be Esri, for example, and in the realm of spatial. It's all data, and that's kind of the bottom line. Whether it's spatial data or data warehouse data, it's all data, right? And we need to be able to, first step, make sense of it before we can use it in our analytics. We have to understand whether it's at a certain aggregation level, what type of data is it, do we need to prep it, do we need to clean it, all these different things. That's what Tableau Prep Builder does, and we've covered Tableau Prep Builder in another webinar. Tableau Desktop is what we use when we want to actually generate our insights, and we do a good session on that as well. And then the next step is when we want to share those insights with our team members, we use either Tableau Cloud or Tableau Server to securely share and collaborate with that content through, say, a web browser. You are currently using Tableau Server at the state, so that is something to again, speak with Kim about and or myself and Henry if you have any questions about that. So with that, I'm just going to hop over to another quick slide deck over here to just introduce a couple of the topics around spatial. Normally I'd jump into a demo, but I think it bears a little bit of understanding first, because spatial data is a little bit different, right? When we're dealing with spatial data, we're dealing with either XY coordinates or what's called geospatial coordinates that have a geometry associated with them. And I'll get into what that is in Tableau. Now, one of the significant differentiators of Tableau, whether you're using Tableau or Power BI or some other tools, is that Tableau actually has mapping built into our platform. So you don't have to have any other third-party add-ins to be able to do it. If you think of, and as I mentioned many times, spatial data is nothing more than data. And what are we using for our analytics? We're using data. So combining spatial and regular analytic data just makes sense. And the fact that we can do it in the product without having to jump through hoops and get other add-ins, which in many cases are additional cost, makes it that much easier. So you'll see that in the course of me going through this. So what types of questions can I answer with spatial data? So like, for example, this is one very, very prudent to me here in Florida. How many of my employees and constituents will be affected by a weather event like a hurricane, right? So the Weather Service publishes these different maps, and wouldn't it be nice to see the intersection of those affected zones with my constituents? Or where is the nearest office for my constituent to go to submit a claim, for example, or ask a question? Or where should I put a new service center closest to my constituents? Or where are my demographics by precinct, or how many potholes are in my district, right? All of these have a spatial component to them and allow us to combine it with our existing data. If you think of like 311 data, pothole data, every pothole, when it's reported, is going to have some spatial coordinate as to where it's located. So it's very easy for us to kind of incorporate that with our data. So when we talk about history, or when we talk about mapping, we've come a long way in terms of mapping over the years. In our 29 releases since version 4, we've incorporated some form of mapping capability. And this chart will kind of show you where we've come from and the level of sophistication and innovation that we've had. So back in 2008, we could have the ability to simply plot points on a map, right? Very easily. And it's very easy to do this, as you'll see in a minute. And then we followed that with the ability to use choropleth maps. That's kind of a mouthful, but basically that means a filled polygon of data, right? So you're seeing maybe color-coded data by state that represents, I don't know, constituents that are under care or something like that. In 2016, we introduced support with Mapbox. So Mapbox is another third-party product that we can integrate with that would allow you, for example, to have custom backdrops on your maps. Like you have a custom, I don't know, border or district map, or district park map, or those sorts of things. Spatial formats. So you can support all the different spatial formats that exist out there now, like GeoJSON and KML, and there's a whole bunch of other ones that we now support. And this is probably one of the biggest ones. It's called a spatial join. So in this case, the data, I guess, is really insignificant, but we're intersecting a data set. Like if you see on the left, it says geometry. That's the spatial representation in a row of data. And where it intersects another geometry, like a lot where two different polygons overlap, right? That would be an intersection. Well, that's simply just like if you think of a regular physical join, right? Or a logical join, they intersect at a certain point, and that gives us a result set. So we can now incorporate spatial type joining, which is very powerful. Density maps, being able to show the intensity of something at a location. Spatial functions. So these are examples of spatial functions, like making a point. So if you have a latitude and a longitude, you can make a point. These are also used in conjunction with each other, as you'll see, to maybe make a line. So you have 2 points that make a line, right? So you can use a make line function to make the line. You can use distance calculations. You can use buffering. So we could see, for example, how far around a point something falls. You can use an area to figure out the area, and you can use a function called outline to actually outline a geometry, which is a nice function to just simply give you a border around that function. And then a big one here is this concept of layers. So every layer in your map, like in this case, there's first a layer that represents districts. And then on top of that, we're laying in points. So I can have as many as I want. I could layer even on top of this other points and maps and so on. So layering was a significant improvement to our product back, and various functions from 21 to current. So with that, I'm going to go ahead and jump out of this, and we're going to jump into Tableau. We're going to start with a blank slate. And in my example, oh, and by the way, as we run through my examples here and throughout the duration, if you have a question, just put it in the chat window. I'll try to glance over and see if there's any questions at any point. We'll hopefully have time at the end to do a little bit of Q&A. But if there's something that's pressing as we're going through, certainly let me know. All right, so in our example today, and this is not going to be a like how to use Tableau demo. It's going to be more about assuming somebody has some skills with Tableau. How would I go about analyzing a particular topic? And the topic du jour is, let's say, for example, that I want to move to Florida, in particular, the Tampa Bay area. And I want to do some analysis on the home prices and home locations. And along with that, I might want to understand, things like how far is the listing away from the nearest high school or recreational facilities or hospitals or fire departments or whatever, right? This is a very typical type of a use case that involves spatial type data. Now, why did I pick this? Well, it's something I think everybody can relate to. If I had picked something very, very specific, like, crime, maps, it may not as be as relevant to you. But I want you to be thinking about how you could use this in your use case as we move through this demo. So what I have done is I've gone to a website called redfin.com, and I've downloaded a bunch of home listing or MLS listing data for a bunch of different zip codes in the Tampa Bay area, because that's where I've kind of focused my search where I'd like to be. Now that data actually, in fact, let me just go ahead and bring up the data over here in our data window so you can see what it looks like. You see here that we've got data represented, property type, address, city, state, and so on. Now, first things first, you notice that Tableau has gone ahead and typed the data source with this little globe icon. And the reason it did that is it understood that that field was geographic. So there's a certain amount of field typing that is done just natively within Tableau. So things like airport codes, area codes for phones, CBSAs, congressional districts, city, country, county, etc. You can read the list here. That means that if you have it in your data, we can immediately map it on a real map without you having to provide us with any sort of shape files or anything like that. Okay. And as a general point, if I kind of step out, here, your question, and a question that always comes up is like, well, doesn't Esri do this? And yeah, the question is, well, yeah, Esri is great about what it does. However, Esri is a very complex tool that is great at creating geospatial applications, right, of a myriad of different types. But one needs to be a very skilled person to understand how to use Esri. I think you could all agree that. I'm not trying to, poo-poo Esri in any way. It is great at what it does. But for example, we can very simply take a shapefile and incorporate it with our data right natively within Tableau. We don't have to have a myriad of different studios to have to do that, okay? So again, you may have further questions on that, and we can tackle that later, but I just wanted to point out, we're great at what we do, Esri is great at what they do, and we kind of meet in the middle, right? We're the analytics end of Esri. So, and other tools, not necessarily just Esri, but anywhere you can surface a shapefile or geographic or spatial data. So back to the information here, and then you'll notice about each listing, we have things like square footage, year built, days on markets, where, all that kind of stuff, right? So these are the things we're going to use to do our analysis in the context of kind of a real life use case using spatial information. Okay, the very first thing we're going to do here, you notice this is kind of typical Tableau. We start with a blank slate here, and we're going to say, all right, well, let me look at all of my different zip codes, right? So I'm going to take the zip code pill here on the left-hand side and drag it in the middle of the screen. And since zip code was a spatially represented item, you'll notice it is plotting it on a map. And I didn't have to tell it that I wanted it on a map. It assumed I wanted it on a map. Why? Because it's spatial data. Right? I could just as easily have, and I'll show you this right now, I'll just clear the screen and drag the zip code field to rows, and I would get a list of zip codes. That's not very helpful to me, right? What is more helpful is the ability to see them on a map. I can even go one step further, and I can change, and by the way, it's showing points here right now. If I wanted to convert these to an actual polygon or a choropleth, let's just say, for example, I wanted to know what the average price was for each zip code. So if I take price and drag it to the marks code under color and make it an average, you'll notice the map will change and be colorized now with, as you can see, as I hover over the different polygon areas, these are the average prices. And the first thing you might be saying is, holy cow, these are expensive. Well, if I had done this demo 2 years ago, what you would have seen were prices about half of this, no joke. So it's insane, is all I can tell you, is that, these prices, and I live in Tampa, I guess I should probably say that. So anyway, you get the idea. Now, while I'm here, I'm going to point out that the map background looks kind of dull right now. That's kind of the default map, but I can always change the background map here to something else. Like what would make more sense here might be a street level map. So let's go ahead and do that. Now you see that I've got a street level map, and let me change kind of the see-through ability of each one of those. So you see that's where my zip codes fall in the east side of Tampa Bay area. I happen to live in the Brandon area here in Florida. So you'll notice each one of the polygons is now colorized kind of light to dark based on the fact that, ooh, there's 2 million average price. This is kind of a pricey area up here, obviously. Now, if I wanted to also maybe do something like show that average price on the map, all I would have to do is also copy and drag that to a label field, and I can now see it. So this is what the beauty of Tableau, right? Easily being able to do some analysis in literally like 2 or 3 keystrokes, I'm able to find an answer to a question. Now, we're not going to leave it here. We're going to actually analyze this from a lot of different perspectives. But the first thing that I want to do maybe is maybe combine that with how many properties within each zip code do I have within certain price ranges? So let's do this. Let's go ahead and create another visualization that, first of all, looks at the count by price bin. Now, I have set up a bin for every 50K worth of price. So all I've done here is said that for all zip codes right now, the sweet spot is around the 350K price range at about 256 properties in that range. And you can see they go all the way up here to 1.7 million. Well, now, wouldn't it be cool if I could add this as an overlay into my tooltip for the map? So let's do that, right? So for each one of these zip codes, I'm going to come over here to the tooltip, and I'm going to add in that visualization. So that is my price bin tooltip. And all I'm going to do is make it a little bit deeper so that it shows more information when I'm viewing it. So now when I hover over that one, you see it's actually filtering down to show me the number within that. Okay, does that make sense? So again, as a typical analysis tool, it's very easy. You noticed I didn't have to do any programming to do this. I didn't have to write Python scripts to do this. I could simply drag and drop my fields in and start doing analysis. And again, as a side note, if I'm a Python person, I can absolutely add in some Python functions to this if I wanted to. That's kind of a topic for another day, but nonetheless, I have this. So you notice as I float around here in the different zip codes. Now, for example, if my price threshold was going to be in the 350K range, I might want to find where I have more of those homes available in that price range, right? So it seems like, that is good. I want to stay away from over here because, wow, they're mostly in the 4s, 5s, and 6s, right? In this area of the county. So anyway, that's kind of the first step there. Maybe I also want to look at some things like, for example, let's add, and this is talking to the concept of layers. So layering means I've already got one layer, which is my zip code. I want to add to it the actual homes as points. Well, where do I have that? Let's look at another spatial function here. You see this, and let me expand this up a little bit. I had the latitude and the longitude that came from the download from the website. So I'm using a spatial function to create it. Now, why did I have to do this? Just as an aside, yes, Tableau can actually plot latitude and longitude by itself without the make point function. But if I want to combine this with other spatial functions like, intersecting and things like that, I need to make it a spatial function. So that's what I've done here. And I'm simply going to take this location as point. You see it's got a globe, which means it is geographic. So as I drag that over here to the marks layer card, it now plots them on the screen very easily. Now what I can do, now you notice on my mark card, I have 2 different mark cards, one representing the points. Let me go ahead and expand this so you can see the point, and the other representing the zip code. They all have their own properties, right? That's how Tableau works. So let's go back to the location as point. I want to add some context to it, like the address and the price, because when I hover over it, I'm going to want to see the average price for that property. And then I'm going to give it some context, like let's make them orange and let's give them a nice little border to make them stand out a little bit more. Okay. And I'm going to make them circles actually, so that um, they stand out about a little bit more. Right now, I can see what the the property is. If I hover over an individual property, I will get. Let me do that. The actual address and the average price. Now, another little cool feature is using something called a buffer. So a buffer would mean I want to be able to determine in a circle around, or a buffer around a point or a line or a polygon, for example, what is contained within that. Now, I'm going to use this in conjunction with the satellite view map, which would look like this. This is me changing the background to the satellite view and then using a buffer function. Here, let me just edit this and you can see what it looks like. All this is saying is around a point for 0.01 of a mile, that is going to be my buffer. And wherever it limits the buffer, so if I wanted to limit down and filter down to an individual listing, I will get a satellite view of that point at 0.01 of a mile. Now, just like I showed you before in my map, what I'm going to go is go to the tooltip and I'm going to add in that satellite view and watch what will happen when I hover over a point. Not only do I get the average price, but I now get the view from the space of, or the Google view of what it looks like, right? The satellite view. So this is really cool. I can't overemphasize. Now there's blank space. Looks like they haven't been built there yet. But again, I'll show you in a little bit how you can use Google Street Level View in a dashboard to do the same sort of thing. That's a really cool effect as well, when I maybe combine this all into a dashboard. The other thing that I can do is I'm going to go ahead and duplicate this, and I'm going to change this point map to be a density map. Now, this density map is very helpful when you have points that are, let's say I had 1 million points on my map. So now we can see the density of our listings. It looks like we have more of the listings down here than we do up here, which I can tell you just knowing the area that it's just denser population the more you go down here, right? So again, just another way that we can look. Now, this would be very valuable, for example, if you were in law enforcement and you wanted to see the impact of crime. And then you could filter down to what types of crime. You could see, street level views and all that kind of stuff, right? So again, a very, very nice way of enhancing the map type thing. Let's go ahead and do a few more things here. I'm just simply now going to take, and this has really not any spatial reference, but I'm going to just take the number of properties again, like I did before, and then I'm going to look at the date they were built and see, because I'm concerned that I want to find more recent homes in this time frame. And I'm simply going to use it as a filter a little bit later on. So just wanted to show you that this is another perspective I could add maybe into a dashboard here. We're going to do one or two more here. Actually, in this case, this has already been done for me, but what I've created is a dual axis chart that is showing me the zip code and then the bars that represent both average price in blue and the count of listings. What this visualization does is allow me to kind of look at 2 dimensions and determine, again, where is the sweet spot? Where is my average price? Let's just say that my average price is around $350. That's right about here. Where do I have enough listings that I want to take advantage of to take a look at, right? So you can see that the average price, actually we could sort it slightly differently. Let's sort it by average price. And now I can see, the ones that are in the 350K range are like here, right? So this is the zip codes that I probably want to focus in on that have, in this case, quite a number of count, the 3, 3, 5, 7, 8, right, for whatnot. So again, just one another perspective. And then one additional way of looking at this might be a scatter plot, where this is showing what is the average price by square footage. And what this is going to say is, as average price goes up and as square footage goes up, I now can see the homes. For example, I'm getting more, as price goes up, if the average square foot is greater, then I'm getting greater value, right? But anything below here means it's more expensive if the price is going up for less square feet. So maybe I want to stick in this realm of homes, right? That gives me the best value that I'm looking for, right? If that's of concern to you. So now, how does this all kind of hang together? Well, if I were to put these together into a dashboard, which I've done right here now I'm able to see, for example, if I wanted to take, like we were saying, let's focus in on only homes that were built in this time frame. So they're newer. They've only been in, actually, let me toggle that on as a filter. And then I want to focus in on ones that have an average value in this realm. So I'm getting more bang for my buck for the average square footage. And then now, right in my looking at which homes fall in the 350K range, I want to focus in on this zip code. And now you see I've got these 6 listings, right? If I hover over, I'm kind of looking at the home. If I can get this thing to focus. My mouse is a little touchy. There we go. So do you see what I did? I combined kind of 3 or 4 different perspectives around analytics, all kind of centered around a spatial context. Okay, and I'm keeping things moving pretty quick here. What I'm going to do is kind of extend this even further. Let me go just bring this up. I've got another example here. Let's say, for example, that I had, now this time, instead of zip code, what I've done is I've brought in a shapefile that I downloaded from my local county school district's website. So they gave me a shapefile for high school zones. So if I were to look at the map done a little differently, let me explain a couple things that are going on here. Okay, this map, I don't have what I have are all of the high schools listed as X's because they're points. And I also have points representing the listings. So my question here is, which of the homes are within a certain buffer zone of my high school? And I can change as a filter over here the radius. Like, let's say I want within a 3-mile radius. Make that 3. Get it somewhere around there, right? So 3-mile radius around each one of the high schools. Now, again, as you guys all know, some high schools are better than others. So what if I'm interested in the Bloomingdale High School District, right? So in this case, what I might want to do is come down here, find Bloomingdale, and highlight only the Bloomingdale listings, right? I did this in a dashboard. And let's say that I want to see this house right here. I click on it, and you notice in the bottom window, I get a Google Street Level view. Now it's kind of smallish view here, but I can use it to move around the view just like you would in Google to see what the house looks like. So again, I'm sure you can think of a million different use cases for how this could work in your world, especially if you're doing things like planning for different locations of where your constituents are in proximity to a service center or some sort of a hospital or something like that. I'm going to extend this out to now looking at, and let me show you some other examples of this. These are different use cases. So for example, these are the couple that we looked at initially, like what is the average price by zip, right? Here we looked at that in ours. I showed you the density analysis. Now this one down here, what if my source is a shapefile? Here's where the ones are actually those polygons are represented as high school zones instead of zip codes. You can see they're different than up here. So this particular Durant High School versus Newsom High School, these are all where the listings fall. And I could use it exactly the same way that I did before by filtering down to a particular, you know, zone if I wanted. And then I take that one step further. Now in my example before, what I did was, remember I showed a buffer around the Brandon High School or the or this is actually a different high school. This is the Brandon High School. But now I did a line calculation and a distance calculation and combined it in the same visualization. So now the distance from the high school to each listing is shown and is colored by the calculation that we did in that visualization. So you can see here that the green represents a shorter distance and the red would represent a longer distance. And that is just a simple calculation. It's a spatial calculation done at the level of the distance between each one of the listings down to the high school representation. This is another one here. This is using buffer. I'm on this one in the bottom left kind of corner of the screen. And what this is showing is that if I'm concerned, I've got say I've got a person in my family, I need to be close to a hospital. I can decide of the different hospitals, like here's St. Joe's South. Let's expand the radius out. And now we can see those dots starting to colorize differently. These would be all the listings that are within a particular buffer zone of that hospital, right? As they go. And then you could filter it further, just like I did earlier, and show the actual addresses and all that. So that's another use case. Another use case over here is we combine multiple layers. What I'm looking at is bus routes. So let me actually go to this visualization as I've defined it out here. And let me kind of expand out a little bit. So what this represents is bus routes. That's the amber colored line, the thicker amber colored line that runs, okay? And then bike lanes are represented by the blue. So my question here is like, where can I take a bike to a bus and the house is close to the bike lane for me to do that, right? So you can see here that this listing would be good because it's right close to a bike lane, which is close to a bus route, right? Again, just another type of an application for how this would work. Let's go back to our use case examples. Here's one that's near and dear to my heart because I live in Florida and we get hurricanes. So this, I believe, was hurricane, it was 2021. I don't know if that was Ian. I'm trying to think. It might have been Ian. But down from the NOAA website, you can download the shapefiles showing the wind zone cones over time. And what I did is I download them every 6 hours, and you can see that my home right here is represented by this dot. And right now in this time frame, so at 2021 07 02 at 1800 hours, I was in the less than 5% impact wind zone. Now, if I were to speed this up through time, I'm still there. I'm still there. Oops, now I'm in the 10 to 20% zone. Oops, now, as time is going on, now you notice the storm is turning, and now I'm apparently getting more and more into the wind zone cones that are not good. They're the 50 knot wind zone cones. So again, very, very impactful. This one on the right is showing me just the listings rather than just my home over time. It's the same data. It's just showing over time how, all my listings are now in the 5 to 10% range and so on. So this might be, for example, in your world, where are, my less my vulnerable constituents, right? And I need to somehow email them all that there's a hurricane coming, and I need to, whatever. You can kind of play this out even further, but um, the bottom line is very, very useful, very valuable type use cases. And I believe that kind of is all the material that I had for this.
I have a question related to the maps.
Yes.
And so I'm trying to I'm making a zip code map, and one of the zip codes just will not show on the map. It's a regular place in North Carolina. It's not a small place, it's not a big place, it's just average size,
Yep.
well-known city. And the zip code does not show. And on the map, it shows one null. And I tried to go in there and fix the data, but that particular zip code doesn't show as not a match. It's not shown in the area at all. So I was
Yeah.
wondering,
So I'm guessing your problem is that, like you said, there's null. Is there actually a row for that data in your data
yes,
set? There
there
is.
is. Mm-hmm.
Can you put a 0 in the data instead of? See, here's the problem. If Tableau doesn't perceive there to be data for a particular zip code, it just won't show it. And that's what usually happens, why you get a blank
Yeah.
instead. So the way around that, and what you can either manually go in and add a row of 0 value, right? Not null, but
Right.
0 value.
Right.
And sometimes what I tell people to do, because let's say that your state has 150 counties. I'll just say zip codes. 10 of the zip codes don't have data. They don't exist in the data. There's no row for them. What you have to do is union a dummy data set that has every zip code with a 0 value in it. So what that does effectively is if you um, union that into your data, you will at least be guaranteed to get a row for that zip code with at least a 0 value. And if it adds it to another row that has data, it'll zero it. You know what I mean? There's no value in it, so it'll be 0, right? Does that make sense?
Right.
The only
Mm-hmm.
situation that isn't really work is if you do averaging and things like that, because it'll say, oh, geez, we have a value at 0. But anyway, that's incidental, right? Does
Okay.
that make sense?
Yep, it does. Thank you.
Yeah, that's one of those things that's been a pain in the butt for Tableau users is like, why is my polygon not showing, right? And it's because it
Mm-hmm.
just doesn't have a value. And
Hey, Craig,
um,
this is PK. Can you do a quick demo of the street view from a zip code and an address?
I'll show you how it's constructed if I
So
can.
I have, let's say, 100 counties, and then I've got a list of zip codes, and then by county. So let's say we're looking at Wick County and all the zip codes of crimes happening, right? So
Yep.
I'd like to know what are some of the services that we provide from our organization to those zip codes, and potentially show the street view of where those services are located.
Yes. So like a service would be a Latin along. Is that right?
Yeah, some kind of government-sponsored services for the families who need services for their children.
Yes. Yeah. Okay. So what I'm going to do, it's kind of hard to like demo building it because I would have to have everything set up for that. But let me find the one that I was just showing a minute ago and just kind of talk through how does this get, because that's essentially what this is. Now, this is actually, um, well, I don't want to get too far ahead of myself, but so the way that this is constructed is I use a dashboard action, and that action essentially is a URL action. Let me see if I can find it here. Yeah. All right. So I don't know if you can see this, but it's called a URL action. And what it's doing is it's taking the input from a source sheet on a select. So I'm on where is my listings located? That's this viz over here. So it knows that there's a point, right? And then the target is a web page object, which is maps.google.com. And then you need your URL, which is this right here, http maps.google q equals layer, blah, blah, blah. And then it's supplementing this with the listings longitude and latitude. You see that? Like I started here, the average of listing latitude, comma, average of listing high school longitude. That formulates this URL string right here, which then gets passed and viewed into this panel right here. There's another way to do it. This is a little obscure because this takes you kind of to a view that shows all these little extra navigation features. There's another demo that I have, and I'd probably be hard pressed to find it right this second, but it's a similar, it uses a slightly different web page object that allows you to just simply plot it, and you just get the view, the street level view, right? Does that make sense? That's
Yeah,
essentially.
that's the direction I actually went with to do that, where you kind of add those your stubs to the primary URL so it can pinpoint. However, when it actually displays on a dashboard, it didn't really show, and it's not very reliable. In other words, maybe there are some cookies or what have you restrictions wasn't really displaying that. Well, that's a direction we went with as well. So
I think part of the issue too is you might need a token, a license token to do that. I ran into that before. In other words, the URL string, and this is going from memory here. You see there's a CBLL here. Oh, no, wait. Layer, no. I seem to remember there was an issue where one had to provide a token, but anyway, yeah, it's a little tricky. I will give you that. I'm happy to send you these workbooks. Anybody that's interested, I can give them to Kim, and and she can dole them out to people. This is public data. This has, I just downloaded it from a website, so it's nothing proprietary. So I can certainly send that to you guys, and you can play around with it to see what I've done. So, I guess I made the point earlier that, you don't have to be a GIS programmer to be able to do this, right? And it seems to me that of the people that I've met, because I'm not say an Esri person, and I'm picking on Esri mainly because, they're probably the industry standard for spatial type applications. And I say spatial applications, right? Do they have visualization capabilities? Yes, but in my estimation, they're nowhere near the capabilities of Tableau analytics. So again, take it for what it's worth. The ability to incorporate mapping into an analytic dashboard platform is really what we're all about. We're not all about creating very, highly sophisticated multi-layer, maps. That a lot of the maps that you saw during the COVID day, we could certainly have done a lot of those maps, but a lot of folks standardized on like the Esri visual analytics stuff to do that. I think, and the main message is every tool has its strengths, its sweet spots, and we're about analytics and ease of use for the end user analytic person. I'll also mention that we've introduced now spatial capabilities in Prep Builder. So if you wanted to be able to do your, that was a limitation for quite a while where you couldn't do some of the spatial, carry along the spatial geometries and those sorts of things in the data. And now we support that to a certain extent. So that's great from a data prep standpoint. A lot going on in spatial. One other thing to point out too, because this question usually comes up. What if I have an address and I don't have a latitude and a longitude? I'm sure somebody was thinking about asking that, right?
Absolutely.
Yeah.
I have that situation now.
Yeah. So the problem with that is that information has typically been beyond a paywall, meaning you just, if we were to incorporate it into the product, we'd have to pay a vendor for every single coding of an address. So for years, we've been trying to work out a scenario where there's a kind of a fair, like, let's say we'll give you the first 10,000 codings of an address for $100 or something like that. And then if you want any more, you can purchase them at a rate of blank for blank, that sort of thing. Because all we're doing, we're not making any money on it. We're just passing it along to a vendor, right? And having said that, I know I experimented around with this. If you're a Python person, you can write and use some of the Python libraries that do geocoding. But I ran into some issues where, again, I needed, like, if you're using Mapbox's API to do it through Python or one of the other ones, I forget what they are now, you need a token, which means you have to have an account, which means you probably have to put your credit card somewhere. So all I'm saying is, we're working on it. We're trying to come up with a model that's fair to our customers. But you can imagine, like, if a person wants to code a couple 100,000 addresses, right? Like you have all these state level addresses that you want to put on a map. You just can't. First of all, it's kind of crazy to want to do that, right? But you have to think about it, I guess, a little bit more from a monetary standpoint. Now, and I've spent a lot of time with spatial. There are a couple websites that you can go to, and there was one called like geoviz.com or something. I'll look it up here. I'll see if I can find it. But they offered, like, you could code up to 200 Latin longs free. Like, you could submit a list in a CSV of 200 at a time in batches of 200, and it would geocode them to lat longs. And then I would just simply run it, 20 times to get 2,000 addresses or whatever, right? But that's a pain in the butt, right? Or if you're more sophisticated and you want to write a Python script to do that, I have friends of mine that have done that, and they've just created a very simple, you could go to ChatGPT and say, hey, create me a Python script that geocodes, and then you download a few Python libraries. Now your problem is you need to have a token for the engine that's going to generate those. But I've done that before, right? Does that make sense? So it's not an easy thing to solve, but we're trying to get there.
Can I ask you about one of the calculations that you did? It's not really related to the map.
No, go for it.
Can you show us how you made those buckets?
Yeah, sure. All right, let me go back to that one here. It's called the price bin tooltip, and I'll just start from scratch. So I had created this field called price bins that it already existed, but to create a bin, you start with what it is you want to bin, like price. You can either do it, there's two different ways to do it. You can either create a grouped field, or this is the easy way. Let's take price, and I go over here and I click on it and I say create. And instead of one of these options, now I create bins. And I'm going to call this my new price bin object. The size of each bin I want to be 50K, 50,000. And then I click OK. Now I have a price bin. When I add it, it will give me all the different price bins from 0 to whatever, K, right? And now all I had to do, sorry?
No, I'm listening.
Yeah,
no, I understand.
I added up here to columns the count of listings, and then I got, and then I toggled on the number, and then boom, there you go. So yeah, and then the other way you could do it, let's say that it wasn't that simple. Like, let's say here, I'm going to create a calculated field. I'm going to do this as my count of homes. And I would say I would have to do an, let's see, if count of homes, let's see here. Actually, I think at the level of zip code, no. Oh, wait a minute, I'm doing the count of homes by, if price, let's say here, if average of price is between, so it's greater than 50,000 and less than, let's see, how do I do this? What you're basically doing is you're creating a very complicated if statement that will have an else if, right?
Yeah.
With all the different ranges from 50,000 to 150,000. But sometimes I've had to do this where each one wasn't 50,000, like it wasn't every single bin was equal, right?
Okay.
That's one way you could do it.
All right.
Yep.
Okay. I was just wondering if that was what you did or if there was, but then you could also use the group too, right?
Yeah, actually you can use group, but grouping is more for dimensional objects. Like there's no option for me to come here and create, well, I guess there is here. I could create a group. Yeah. See now this is a little quirky because this is giving me the actual each individual price as it exists out there. Right? These are the prices I believe. So like I would have to say, give me here, let's group those. That will be my 14K to 110K homes. And then I would do my 112 here. I'd group those, and that would be my 112 to, you see, to 149. Okay, this is like a custom group, right? And then I would do this group. You see what I'm doing, right? 149K to, what is that? 209K. And now I've got all these groups, and maybe the remaining one I'm just going to call other. Just include other. So that's other. So now I've got 4 groups, right? And I could, let's call this my price group. And instead I'll just use this, right? So that's how I created a custom group that way. Yeah, it's like anything in Tableau, there's multiple ways to skin a cat, right?
Right. It looks like the if statement or a bin is the best way to go.
It's easy. I mean, it just takes you 2 seconds, right?
Yeah.
But again, if they're equal amounts, right? Yeah. So
all right,
well,
thanks.
good. I'll go back to the slide deck that had my contact info in it. Now, you probably recommend that you go through Kim, but we're available if there's any use cases that you want to talk through that you need more assistance with. Certainly, willing to get on the phone with you to kind of talk through those things.
Thank you, Craig, again for completing this series for us, and we look forward to the next one.